Group project. All right, so we're going to be working on deviations here, and I'm now recording. So we're going to be doing the deviation between the budget profit and the profit. So a couple ways we could do this, and one way, let's build the column chart that we may typically see, the one that looks like this. Why don't you go ahead and make that to start?
Between budget profit?
Budget profit and profit. It's by each of the products of the main columns. So when you're done, it should look something like this. I did do it. So I'm going to drop product into the columns. I wanted to let you guys try it yourself. Then I'm going to do it. I'll do it the slow way, then I'll do it the fast way. I'm going to drop budget profit into the rows. And then I'm going to drop profit. If I did this, I'm going to end up with two graphs, right?
Yep.
I'm going to put it right here. And then I have to still go over here to show me and say I want the nested columns or side-by-side bars. The other way, that's the fast way, is I should just be able to say product, budget profit, and profit. I'm control clicking. If I'm on Mac, I'm command clicking, so I'm highlighting all three of those pills, all three of those fields. If I'm on PC, I'm control clicking. And then I can just go over here and click the side-by-side bars, and it just makes it. Fancy, right? That's the fast way. Okay. But now, how would we make the visualization like this? So this is budget profit. This is the percent deviation from budget profit represented as a percent. The way you would do this is you would create a calculated field. All right? So create a calculated field, and remember the sample data, this is done with a previous sample data set. It might look slightly different, but it's going to look very similar to this. So try to make this, and then we'll demonstrate it up here. And work together on this. Don't just be stoically silent and struggling. Ask your neighbor. Hang on, I'm moving it.
Okay. This is
drop it. I think I have it.
So I got this. You had the same thing.
So what's the calculation? How are we going to calculate the deviation? Profit and the budget profit. So how, but what's the calculation you're going to use?
Budget minus actual
Budget minus actual
divided by budget.
divided by budget. So if you did that, hang on. If you do budget minus actual divided by budget, if you're better than budget, what's it going to come up as? A negative number, right? So if you reverse it, you do actual minus budget divided by budget. Now if you're doing better, you'll be in a positive number, right? So you want to do actual minus budget divided by budget. And then you have a little bit more work to do, so keep working on that. So if the actual's 2 and the budget's 1, it would be 2 minus 1 divided by 1, which is going to equal what? 1. You can represent that as a percentage, right? But what if it's 200? Well, it works. You just have to make sure that you think this through a little bit more, because there's some other stuff going on here that I want to see if you guys can sort out. Why do you think, so I know that many of your y-axes are adding up to like 100 or 200. That's not a percentage, right? What's going on there? Because you're using a sum aggregation.
What? Oh.
You're using a sum aggregation. So for our case, for our purposes for this exercise, just change it to average. And it should look something like this. We can always change the color. So I was giving a presentation on Friday, and I have to tell you about what they said about color, the use of color in my presentation. So when everybody gets here. Ah, boo, boo, boo. Because I changed the aggregation, so it went back to the default. All right, there we go. I'll wait till everybody's done, because it has to do with red and green. Yeah, yeah, I got that. We'll do that after. We'll do that after spring break. Okay, are we here now? Most everybody? So in most months, we are averaging below the budget.
Yeah.
Yes, ma'am. You're,
Yours is backwards.
and how do you check yourself? Go back to the previous one and say, yep, lower, higher, lower, higher. Am I wrong? Oh, because this is average and that's sum, so never mind. All I really wanted us to show is that we'd have to do this calculation, okay? All right? So, but let me tell you something about red and green. I did this presentation where I was presenting like what papers I had and which ones were under review and which ones had been published and which ones were in what's called a revision, which is really good. But my published ones were blue, my working papers were green, and my revisions were red. And I just kind of picked rainbow colors because the color has no meaning, right? But they're all like, well, why are revisions red? Because that's good, right? And then they got into a big fight in the room about why it was okay to have them red. I just stood there and watched them argue. But one of the things that was funny was that the people who were from Asia were like, well, red is good. Like when the stock market goes up, it's red numbers, and when it goes down, it's green numbers. It's all backward, right? So we talked a little bit about color. We'll continue to talk about color as we go, but color matters as far as your audience goes. All right, we'll clean this up a little bit more when we do our tutorial and our workshop on deviation. But let's move on to distribution real quick. We'll clean that up as we go. One thing we might have wanted to do is put some annotations about what's acceptable ranges or what's good, positive. But for today, we're not going to worry about that. All right, let's talk about distribution analysis. You guys have done this forever, right? Why do we look at distribution? Because we typically do. What does regression do? It assumes that there is the mythical average customer or average case, right? And so you guys know how the regression line happens, right? If you're just doing standard linear regression, you know what happens, right? You draw a line through the mean of x, and you draw a line through the mean of y, and you draw a line that's your linear path, and then the computer. I mean, for all intents and purposes, what's happening is we're tipping that line until we get the lowest residual sum of squares. That's basically what's happening, right? And we typically look at our averages, like our customers, as being an average. So we're going to treat, now we don't do this anymore, but we for 100 years we treated, okay, what do 18 to 25-year-old girls in Texas like? Because the idea was they're all basically one category. Right, so we can do a distribution to kind of say, hey, there's something more than this average customer, right? So every regression function that we fit's based upon the mythical average, and the idea that maybe there's a uniform distribution background population that we're kind of sampling from. All right, you've all seen these things a million times. We're not going to talk about them very much, but the idea here is that there's lots of things that distributions can tell us. We know your standard normal. We're not going to go through a whole bunch of different kinds of distribution shapes, but the thing I want you to do is think about when you're visualizing distributions, what can you learn from them, all right? So when you see this, you say, oh, okay, this seems about right. I can now do my regression. But we perform distribution analysis because the world isn't uniform, nor is it standard normal. But we also perform it because our statistics assume normality. If you're running stats against outcome variables that are not distributed properly, you're going to be getting biased results, right? But we perform distribution with visualization to try to recognize and communicate information about our data, right? So in business, we talk about 24 to 44-year-old males. That's kind of this demographic that all the sports teams want, right? Residents of Waco or residents of Delhi. But the reason we tended to think of the world that way is because it was our inability to view beyond the mean, right? We couldn't get individual level shopping information. We couldn't get individual level purchasing information or whatever, right? And so media technology allowed for broadcasting, but not for narrowcasting, right? But the distribution is going to help us understand how to segment our groups if we need to, and narrowcast, not individual cast, but narrowcast more efficiently, all right? So you all know this stuff, right? We have to determine the shape. Is it curved or flat? What's the direction of the slope? How many peaks? Are there gaps? Gaps and peaks are the interesting thing about distributions. If you run a distribution and you see more than one peak, or you see gaps, you know there's something strange going on, and you have to investigate more directly. All right. So we know that the world is always skewed, right? You can't have people who are negative 20 years old to balance out the people who are 20 years old, right? It doesn't work. There's so many numbers in the real world that can't have a second side to them, right? So the world's naturally skewed. You've seen this 100 times. What does this tell you? Single or multimode? Do I have a question on the next page? Yeah. Right. So single or multimodal. Now, technically, let's not get too wound up in technicalities. When I'm talking about multimodal, I just mean there's more than one peak. The technical statistics thing about saying multimodal means what? They're the same height, right? There's two that are the same maximum, right? Let's just talk about the fact that we have two peaks. What does something that has two peaks mean? Talk about amongst yourselves. What does that mean? So you're basically looking for the distribution, and basically you're saying X leads to Y, but Y looks like this, right? So what's going on? Talk to each other and see if you can sort that out. We would expect that if X leads to Y, that Y might be distributed like this. But if it's just distributed like this, what does it mean? Yeah, sorry.
I checked. I don't
Yeah.
wear anything.
You business fellows in your...
It's gone now.
Oh, you can't do QB anymore?
You can't do it in a cement. They don't want
Oh, a special one
to. You
anymore?
have to do the actual the real one.
So what does it tell us? Who's got it? Yeah. Now, obviously, it tells us. It could tell us a lot of things, but in general, what is it telling us? So let's pretend that. Sorry. Yes, that there's some other process going on. It could be that there's two groups. So let's say we were trying to represent number of defects per shift or per hour, right? And you'd assume that the number of defects per hour would have some sort of a mean, and it would be pretty evenly distributed on either side of the mean, right? It would be like this, like we'd expect it. But if we had something like this, what might we, let's say we visualize our defects per hour, what do we have here? Maybe two factories, two shifts, or two products. Right? Two lines, right. And so the idea here is that when you say X leads to Y and you end up with this, you're dealing with something else. You're dealing with a second process. And really the only way you notice that, you don't notice that from any sort of this descriptive statistics of your data. You notice that when you look at it, right? Okay, we know, you know all this stuff. Spread means the dispersion from lowest to highest. Spread's important, but it doesn't tell us a lot. I mean, it tells us that one variable might have a wider spread than another, but that doesn't mean anything because some variables will have a logical wider spread versus another. Center helps us to understand more. It's the basis for determining skewness. But what if you got a distribution that looked like this? So it's got a kind of a bell-shaped curve in the center, but there's no ends. There's no tails. Talk amongst yourselves. What might that mean? And again, this could be defects per batch. Defects per batch. Why would we have everything in the middle but not the ends? And again, to get them on both sides, it's going to be around the mean, you know, right? So, or maybe it's easier to tell you what this one means if I ask you, what happens if you get a distribution like this? Especially if it's like defects per batch. Or deviation from millimeters deviation from standard. Average average deviance from the
Then you're not meeting your specification very well.
or at least what the company shipping me isn't meeting the specification well, while what they might be shipping somebody else is much closer to tolerance, right? So one of the reasons that we look at our data is maybe we have to understand what's happening in our supply chain. This is a thing. If we saw this, we would know there was a problem. We would know that doesn't happen naturally, right? If I'm talking about like tolerances and differences, how far are my widgets from tolerance? And I'm just getting the tails. I would assume my supplier's giving the middle of the curve to somebody they like better, right? And that they're kind of sending me the garbage, right? And so you have to look at these things, okay? You're right. If you try to perform a regression with data that looked like this, it would be heavily biased, right? So again, we talked about this way back in like the second week, that we do visualizing before we do our analysis just to make sure that we're trying to tell that we're telling the right story. It helps us to build our story. It might help us to know that we're telling the wrong story. Now, best practices for distribution, not a pie chart. When is the right time to use a pie chart? We won't talk about it because it's on the exam, but make sure you know when to use a pie chart, when not to. All right? Histograms, this is what we tend to use more often than not, is a histogram. We're going to look at that in a second. There's a thing called a frequency polygon. Have any of you ever heard of a frequency polygon before? They are the weirdest things. They are terribly hard to understand, and people still say that they're a good way to do a distribution. They're in the book, in the reading on distribution. When you read it in the book, you'll see a frequency polygon, and you're going to say, I don't ever want to use a frequency polygon. And I hope nobody ever shows me one because I won't understand it. Stem and leaf, there's a cool blog here on how to do a stem and leaf in Tableau. But honestly, if you want to do a stem and leaf in your stats program. Okay, it's way too hard to do in Tableau or box plots. All right, so let's try these things here a little bit. What's a histogram? Right, the classic display for the distribution. Tableau will let you create a histogram in about 5 seconds, but often the histogram that Tableau comes up with may be less not wrong than something else that you can do. All right, so we have to become more not wrong with those as we go. All right, notice here, these tell different stories. These tell different stories. What's the difference between these different histograms? The size of the bin. All right, so default, Tableau creates bins based upon the overall range. They're only sometimes the correct size or the most not wrong size. And you should experiment with bin sizes. The bins help you tell the story without lying. So we can change bin size. We can even create custom bins. Now, what is the best practice for the bin size? all the bins should be the same size. All the bins should be the same size. But sometimes you might have something that's like super skewed, right? And so you have all this stuff here, and then you've got like one way out. And you might want to say, okay, 100 to 200, 200 to 300, 300 to 400, 500 plus, right? Just depends upon your story. We just want to make sure we're being careful, all right? So load the coffee shop data again and create a histogram on sales. Now, if you use show me, let's do this together. If you use show me, we're going to use sales. And if we go over here to show me and we click on histogram, read what it says it's going to do. You need one measure. So I've clicked on sales and it says I can do it. And look what it says it's going to do. Creates a bin field. First time I opened up Tableau, I thought, what's a binary field? I was thinking binary field. It just means bins, all right? So go ahead and click on sales, come over to show me, and click the histogram. And if you look up in the dimensions area, it doesn't put sales into the columns up here. It puts something new called sales bin. And that's up here in the dimensions, sales bin. And you see that we kind of do have that idea of kind of a two peaks, right? And what have we done? Basically, it's count of sales in each one of these columns. And so it's 400. So this is $100. This is amount of sales, right? This is the amount of sales. And so this is a $500 sale. So our coffee shop has some sales out here in the $500 to $700 range, and has some sales up here that are in the $100 to $300 range. Obviously, this is not a coffee shop doing sales to you as you just come up and get your latte. It's probably that they're selling stuff to businesses to have coffee, like offices and stuff, to have coffee for their employees and stuff like this. So you might have two kind of order frequencies. Maybe the typical people order monthly, and maybe some other people order quarterly. Or you might have small and medium businesses and large businesses. All I can tell from my histogram is that there's probably two sets of activities going on here. And I don't know what they are yet, but I can tell that that's happening, all right? But now the question is does this tell the story about our sales, all right? So let's try to experiment a little bit with changing the bin size. And instead of just changing the bin size, let's actually duplicate this. Actually, let's first right-click on sales bin, and we're going to edit it. And let's take a look at what's going on in this dialog box. You could have created this bin by yourself. It wouldn't have been any problem, right? So the size of the bin is 34.3, right? And that's what it got from looking at the overall distribution, from the overall, yes, the range of the data, all right? So let's call this sales bin, and let's just call it by its name here. Let's just say default, okay? And now let's right-click and choose duplicate, and let's call the second one sales bin 10, and let's make the bin sizes 10. Okay. And then let's duplicate that one and call it sales bin 25. Okay. And just for fun, instead of duplicating this next one, so we're going to have a sales bin default, a sales bin 10, a sales bin 25. Let's right-click down here on sales and create a bins. So this is doing it manually. We're doing manually what Tableau did for us, just so you can see we can do it. We're going to call this one sales bin 50 and make the size of the bin 50. You see that in the end, nothing is different about these sales bins fields besides the first three. We were kind of working off the one that Tableau created, and the 50 one, we created that one from scratch. And now I'm going to make one more and call it sales bin 100.
Why does it come up as blue instead of green?
Why does it come as blue instead of green? You mean the one I created versus the one it created? Well, that's an interesting question as to why that's the behavior. So mine, it's considering discrete. The other one, probably because it created it based upon the function. It just makes it continuous by default. That's a great question. I've never actually seen that. I've never actually noticed that. Let's just make them all discrete because it makes sense for them to be discrete. And now what I'd like you to do is just make a histogram. Now let's make a histogram from scratch. Okay, so this is what Tableau did automatically. So let's make another sheet. And let's drop sales bin 10 into the columns. And then we're going to put sales into the rows. But instead of sum, we're going to use count. And what's the other? Now, this is a strange thing. I don't know why Tableau does this. Well, in this one, it didn't do it as much. This actually, they fixed this in this version. It used to end up looking like mine. Why is this not a histogram? And this is a histogram. Sorry? The bars have to be connected. How do I connect my bars here? If I go into size and I just make them a little bit bigger. There we go. I now have a histogram. Okay? All right. Now make one for each of your sales bins. So make one for your 10, your 25, your 50, and your 100. And then compare each of those graphs and decide which one do you think shows the shape of the data without showing too much shape of the data. You should end up with a bunch of choices that kind of look like this. I'm not going to bother doing it right now. I lied. I decided to go ahead and do it all. And so you should end up with something that looks like this. I got to make them fit right. There you go. So when you're finished, it should look something like this. And then which one is the one you'd pick?
Depends on the story you were wanting to tell.
Perfect answer. Depends on the story you're trying to tell. If your story is at first just to illustrate the fact that there's two distinct groups going on, which one would be the best one to show that? There's not a right answer. Either default or 50 to me seems like it's going to show that. But if you had another reason, so here's what I was talking about before. You have a whole bunch under 100, a whole bunch between 1 and 2, a whole bunch between 2 and 3, and then you kind of have this stuff going way out like this. You could actually create another field that that bins this up a little bit differently. Let me show you how you would do that. So I'm going to create a custom bin for this. I'm going to take sales. I'm going to say create a calculated field. Oh, shoot, it's way over here. And I'm going to call this custom bin. And this is really kludgy, okay? This is not terribly normal to do. If sales is less than 100, then 0. I don't need this. I'm such a creature of habit. Else if So take a look at what this is doing. It's saying if sales is less than 100. Oh yeah, it should have been less than. I'll reverse all those. Thank you. So if sales is less than 100. Yeah, that other one wouldn't have worked. Okay, so if sales is less than 100, then 0. Else if sales is less than 200, then 100. Else if sales is less than 300, then 200. It's basically, I'm just saying, which 100 bin are you in, right? You're in the 0-100 bin, the 100 bin, the 200 bin, the 300 bin, the 400 bin, or higher than 500, right? But let's say your number is 50. What's it going to end up?
0.
But isn't 50 less than 200 and less than 300 and less than 400 and less than 500? So which one would it be?
With that equation.
It goes to the sequence of operations, plus it checks the first condition.
Right. If you meet the first condition, it doesn't matter if you meet any other one. Okay? So the reason this works, the reason it just works, that I don't have to say if it's between 100 and 200, is because I already got rid of everything under 100 with the first check. Now I'm just looking for things under 200, and if I'm still checking them, it means they were more than 100, right? Because if they were under 100, they're at 0 and they're gone. Then if they're under 200, I know they must be 100 to 199.99 because the hundreds are gone, and so on through the list, right? So does that make sense why that calculation works? It's a basic programming thing, but I know a lot of you have been taking programming classes, so that's why I covered that. All right? So now let's hit OK. And now if we use this custom bin, actually I'm going to make this discrete. And if I make custom bin as my, I got to make it a measure. Sorry, a couple more things I got to do. I got to make this a measure. Sorry, a dimension. So I got to make a dimension. Now if I put this into the custom, and now I do my count of sales, all the ones that were at 100 and above are out here, right? So what did we do? We basically just added together everything that was 500, 600, 700, 800, 900. That's what these are, all right? I got to count it. Sorry, count it. There we go. That looks right. Okay. So the first columns should be exactly the same as my 100 bin one. And they look like they are. A little over 1,000, a little over 1,800, a little over 1,000, a little over 1,800. But this one that's down here that's got 311 is the sum of this one and this one of all these. So you see what I've done here? I've highlighted these columns. I've moused over, and you can see right here what it's, you can see right here, it says for the 5 items selected, there's 331 items in that count. When I go to my new sheet, if I mouse over, count of sales, 331. So I know I did them all. Make sense? What would I do here? I wouldn't want it to be called 500. I would edit the alias, and I would say 500 or more. And that would be better, right? That was a weird thing to do. You almost should never do that, okay? But you could. I wouldn't do that if this 500 or more made it go back up, right? I would only do this if 500 or more still was like lower than the one before it, right? Because what have I just done now? I've changed my data to make it look like there's some new process starting here when there really isn't, right? But I was just kind of using that as a demo. Oh gosh, it's already 1:55. All right. So, do me a favor and convert. Instead, let's take a look at this visualization. Histograms are great, right? They tell us a lot about the shape of one variable. There's another visualization we can use, which is a great visualization invented by John Tukey to show distribution. And you've also used this one 100 times. Come on. Box plots. Box plots. Why are box plots in our world? Why don't we use box plots? Why do we typically use use histograms? Yeah.
So many people will be able to.
People don't know what box plots are, right? And it's a tragedy because look at how much more information we can put on the screen in box plots than we can in histograms. Right? That histogram took a ton more pixels than a box plot does. And in this one, we can really compare these distributions of the sales by product in a way that we couldn't do. How would we do this with histograms? We'd have to have what, 12 or 13 histograms and then try to figure them out by going back and forth. When in this one, we can do it together. Let's just quickly together build this. So in Tableau, it's on the show me. So if I just do, I think, I've never done this the easy way. Let's try this the easy way. Let's click product. Let's click sales. Yeah, and let's go over here and click box and whisker plots, and it should just work. Never tried this, and I know I'm recording this for posterity, so I'm not quite sure what's about to happen. All right, so that worked, but it didn't actually, what it did instead is it made each of the products the distribution, right? What we wanted was we wanted the columns to be product, and so what else do we need? So we want the columns to be the product. Dang it, why is it doing that? Why is it doing that? I know there's like a click I'm forgetting. All right. Oh, maybe I have to do it this way. Now, all right. I will remember how to do this by next week, and I will tell you then. I'm just forgetting off the top. I just am not remembering. It's so easy, and I just drawing a blank. Let's move on to the next topic because you kind of need this for your group project, and I really don't want it to wait too much longer, okay? La 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 la. It's going to skip dashboard actions. We don't have time. Let's talk about this. Date functions. How many of you have used date functions in Excel? What are some really great things you can do with date functions?
Days.
You can do dates, right? But
So
what?
you can always have like today's date.
You can always get today's date. You can always compare how long ago was a day compared to today, right? So you can also move dates to determine the number of days, weeks, months, and years between any two dates. The most common ones you're going to use are date diff and date add. I think they're pretty self-explanatory what they mean. Date diff means if you give them two dates and you have to give it the unit you want to know as far as like You want to know how many days, how many weeks, how many months, or how many years between the dates. Date diff, if you give it 2 dates and the date part you want, it'll tell you how many between. And then date add should probably have been called like date move, because if you do date add, you can move, you can add months, weeks, but you can also go backward in time by using negative numbers. So it shouldn't have been called date add, it should be called like date move. But anyway, let's take a look at how these work. The first thing you need to know is this table, which are the parts of the dates. Because all of these functions take this thing called date part, right? And that's just, and it's literally written out year with quotes. And it's case sensitive, right? So it's year, quarter, month, or these other ones, all right? This is all in the documentation. If you went and looked up Tableau date diff function, it would give you this table on the function, just so you can remember what they are. But we're typically going to use year, or month, or week, or day, right? That's pretty straightforward. There's just the word, so it doesn't get that hard. It's just good to know that there are these other choices like day of year, weekday, minute, second, etc. All right? Fiscal dates. If you work for an organization that deals with a fiscal calendar that is different from the normal calendar, what does that mean? It doesn't matter when you're just moving things, counting the number of days, but a year means a different thing, right? And a quarter means a different thing, right? So there's also a way to set your fiscal year, okay? So there's a thing called fiscal year start, all right? Now, how do you set that? If you go to your data source and you right-click on the data source, there's a thing called the Date Properties menu. And if you click on that, you can actually set up the fiscal year start. It only lets you pick a month. It doesn't let you say our fiscal year starts on the 4th of July, right? But any company who did that would just be too weird to work for. You should leave immediately. But pick the month that your fiscal year starts. We're not going to worry about that too much in this class. But this could help. This could help in some of the TSTC things with the weird dates that they use. You may think about using the fiscal year as a way to handle that, okay? Don't know if you need it, but I wanted to show it to you because it could help, specifically because they're dealing with multiple calendars, all right? But you can only set one fiscal start per data source, all right? Date diff, all right? This is easy. This is the syntax. Date diff, date part. The date part is that table of words that you need to know, week, month, day, year, etc. So the first thing you say is, what's the week that you want? And then if you ever wanted to give, now what you would normally do is you would put a field name here, which would have a date in it, and a field name here that would have a date in it. But in this case, I'm showing you in hard-coded just so you can see what's going on. And then the first day of the week is optional. So you can actually set the first day of the week to be Sunday, Monday, Tuesday, or whatever. Right now, if you went and looked at your calendar, you'd see that what? What day of the week is the 22nd of September 2013? Look it up. What day of the week was the 22nd of September 2013? Sorry? Sunday? Is it? No, it doesn't say it. Oh yeah. Thanks. Sorry. Forgot to put it here. I was like, gosh, why didn't I write that on the slide? And then it's, oh yeah, here it is right here. Sorry. Should have put that more, should have annotated that better. Right, a Sunday. So if the start of the week is on a Sunday, and we're asking for how many weeks difference are we going from Sunday to Tuesday in the same week, it's 0. But if the start of the week is Monday, and we're going from Sunday to Tuesday, the week's difference is 1. Okay? Now we're typically going to use that for some relatively narrow reasons, but this one we're going to use all the time, right? It's the same basic syntax in all these date functions. Date add, date part, the interval, which is just your number, right? And then the date, again, which we would normally put in as a field. And what's that going to do? This is going to say add by months, 3 months to the 15th of April 2004 becomes the 15th of July 2004. right? Let's use that to change how we did something last week. Let's go back to Tableau. And what I want you to do is open up the Superstore data. Open up the Superstore data. And remember in the Superstore data which we did last week, in order to do that bullet graph kind of thing, we did a calculated field that calculated 2016 sales. Now the data in this database ends in 2017. So let's pretend that we don't have any sales in 2018. So we just want to make a field that says last year's sales. Last year's sales. So I'd like you to to work together to use, you're going to use date add, and you're going to use the today function, which is going to return today. And what you want to do is using those two functions, could you make a new function that only puts the sales in if it's last year's sales? So remember how that worked last week.
Why wouldn't we just put 2017?
Because I want this function to work every year without having to go back and recreate my workbook for every year. I have to go back and find every place I hard-coded in 2018 or 2017. So what we're going to do is we're going to do if something, then sales, else 0, end. That's what you want to create. You want to create a field called last year's sales. And I'll show you real quick. Here we go. I'll just remind you, bless you, this is what the 2017 sales function would look like. If the year of order date equals 2017, then sales, else 0. That's how we did it last week. Now I want you to figure out how to do that without having to hard code in 2017. And you can use that by using date add today, and you'll still also need the year function. You're going to need 3 functions. Must be an exam in here next hour. Lining up. So what are we going to do? We're going to find last year's sales. So how do we figure out what last year is? Well, we got to start with what this year is, right? We can use today, right? That's this year. Do we do the year of that? Not yet. We take this and we move it, and then we take the year. Take this and move it, and then take the year. Let me get the date add function here, right? So we're going to basically use date add. What do we want to move by? Years. How many years? -1. Because we want to go back in time. And what's the date we're going to put in here? The date we're going to put in this function? Today. So the date add function is going to look like this. Date add, parentheses, year, comma, -1, comma, today, which takes open and close parens. So the date add is going to look like that. But that's just going to give you a new date, which is what? 1 year before today. Then you still need to do something to pull something out. Is there a way to put, you mean like comments?
Yeah.
we will talk about comments. Yes, there is a way to put in comments.
So,
And then what I'm going to do is I want the year of that. So I'm going to wrap that whole thing in a year function. So date add shifted today by 1 year. So it found what is the date 1 year ago, and then I can get the year from that. So that would be 2017. Does that make sense? And so that function, when we finish it, should look like this. I'm just going to show it to you. It should look like this when you're all done. See how this works? If the year of order date equals the year of date add year minus 1 today, so if the year of the order date is the same year as what the year was 1 year ago today, then put sales in. Was that too confusing? So, what if the year of the order date is 2017, for instance? Well, remember, this is 2018, right? So what's the year of this going to evaluate to? We're going to do date add year minus 1, so it's going to be 2017 because we're using today. We could put any date in there. We could put 4 BC in there, right? But if the year of order date equals the year of today minus 1, that's the way you would look at that, right? The year of today minus 1, then count the sales, else 0. And you'll see when I put these into my tableau, did you get this one in here yet? When I checked myself to make sure I'd done my calculation right, and I did the 2017 sales field the way we did it last week, and I did last year's sales the way it was with the formula, and you can see that they're equal. Now the beautiful thing about this is that now last year's sales is always last year's sales, right? Now if I wanted to, I could do like last year's sales to date, like to this point in the year. That's a little bit more complex calculation, right? Because what I have to do is first say, is the year, I'd have to add to this formula. Because what I could do is I could do, and again, don't think about this too much because it'll make your head bend. But the first thing would be if the year of the order date equals the year of a year ago today, then, and if like the month and day are less than or equal to, right? You'd have to do all that. But anyway, well, actually all you have to do is if the year of the order date equals last year and the year of the order date is less than a year ago today, it'll be sales today. I'll show you how that goes. I'll do that in a demo online. I'll show it to you. All right, we're out of time, unfortunately. So before we stop, I'll post this. I'll post that other cool thing, which would be sales year to date. Sales to this point last year compared to sales to this point this year. And what I will do is, again, you have absolute freedom to use anything you want on the exam. You have absolute freedom to contact me and ask questions about the exam. And if I can answer the question, I will. And there's some questions I won't answer, but some questions I will. Somebody found a typo in the first version of the exam. I fixed that typo, so don't worry about that. But then, when we get back, during spring break, you'll see a note from me that's going to say, contact your team and pick a meeting time the week we get back, okay? I'll try to do that this week so that you don't have to try to find people during spring break, okay? Anything else? Right? While you're gone on spring break, please do not mix the two things. Mix the following: alcohol and high places, okay? Just don't mix those two things. We don't need anybody falling off anything drunk, okay? But anyway, have fun, be safe, don't do anything dumb, all right? See you when you get back.
Okay, so here, I'm going to just do like day minus 365.
You can do that too. Right, you can do that too. Except you still got to get the start of the year, right? Because You can always find a year ago from today. The question, the hard part is it in last year and before today? Before a year ago.
How much protein is it?
So if you did it, show me all the sales that are before a year ago today. It would be everything from that year up to this point and all previous years. So you have to first say, am I in the right year? And then is it earlier than the second year? I'll demonstrate.
Okay, so it would be two 365.
No, it would be a 365 and this. In the right year, and is it less than the other day?